My guest today again is Javier Vinós.
Your audience needs to know that this is a very important issue because we are just gone through the warmest year in record in 2023, and it is very likely that 2024 will be even warmer. And this is all a natural climate event. And the United Nations and the climate scientists that work to push the climate emergency are using it to promote an agenda by blaming this natural climate event on human-caused climate change, when actually is not only natural, but it will fix by itself. You know, by waiting a few years, all this will just go away. The climate event of 2023 was truly exceptional, but the prevailing catastrophism about climate change hinders its proper scientific analysis. I will now present arguments that support the view that we are facing an extraordinary and extremely rare natural event in climate history. Since the planet has been warming for 200 years, and our global records are even more recent, every few years a new warmest year in history is recorded. Despite all the publicity given each time it happens, it would really be news if it didn't happen, as it did between 1998 and 2014, a period popularly known as the poles. Since 1980, 30 years have broken the temperature record, so what is so special about the 2023 record and the expected 2024 record? For starters, 2023 broke the record by the largest margin in records, 0.17 degrees Celsius. This may not sound like much, but if all the records were by this margin, we would go from plus 1.5 degrees Celsius to plus 2 degrees in just 10 years, and reach plus 3 degrees 20 years later. Moreover, to produce so much warming, almost the entire globe experienced above average warming. 2023 was a year of real global warming, although most of the warming occurred in the northern hemisphere. As a result, one of the major databases, Berkeley Earth, has exceeded the plus 1.5 degrees Celsius limit for a full year for the first time, and 2024 promises another temperature record. Crossing the dangerous warming threshold so early has caused some confusion, exacerbated by the fact that not much difference seems to be noticeable. Even Arctic ice remains above the average of the last decade. And if we've already crossed the line and the climate is beyond repair, what's the point of trying? But the authorities have been quick to point out that even if we are about plus 1.5 degrees Celsius in 2023 or 2024, we will not have crossed the threshold. There is a catch. The global temperature is not the temperature of 1 month or 1 year, but the temperature of the linear trend of the last 30 years, which, according to the European Copernicus system, is plus 1.28 degrees Celsius, and is expected to exceed plus 1.5 degrees in 10 years. In June 2023, the North Atlantic experienced a heat wave unprecedented in 40 years, with temperatures 5 degrees Celsius warmer than usual. Carlo Buontempo, the director of Copernicus, said that the world was entering uncharted territory, and that we have never seen anything like this in our life. To understand what has puzzled scientists so much, it is necessary to look at the evolution of the temperature of the Earth's oceans throughout the year since 1979. On average, the Earth's oceans are warmest in February-March and coldest in October-November, with an intermediate maximum in August. This is an annual cycle caused by the tilt of the Earth's axis, the arrangement of the continents, and seasonal changes in atmospheric circulation and albedo, a cycle that has never been broken as long as measurements have been kept, until 2023. This year shows an accentuated warming since January, leading to daily temperature records since the beginning of April. But what is absolutely astonishing is that the ocean continued to warm in June and July, and reached an annual maximum in August, something that has never happened before. And the warming through August is staggering, about 0.33 degrees Celsius above the 2016 record, which is huge for the ocean. After that, the annual cycle begins to behave normally, but at a much higher temperature, which is slowly falling. In June 2024, after 415 days of record temperatures, the ocean is still about 0.2 degrees warmer than it should be. Buon tempo means good weather in English, and his phrase, "we have entered uncharted territory," has become very popular. However, it assumes that we have reached and will remain in this situation, whereas the data suggests that this is a one-off anomaly with diminishing effects. For now, it tells us that nothing dramatic is happening as we approach the politically established warming threshold. Gavin Schmidt, director of NASA's Climate Monitoring Institute, also uses the expression uncharted territory when he explains that the 2023 anomaly worries scientists, saying that climate models cannot explain why the planet's temperature suddenly spiked in 2023. Not only was the temperature anomaly much larger than expected, but it occurred months before the onset of El Niño. In his own words, the 2023 temperature anomaly has come out of the blue, revealing an unprecedented knowledge gap, perhaps for the first time since about 40 years ago. It could imply that a warming planet is already fundamentally altering how the climate system operates, much sooner than scientists had anticipated. So, according to Gavin, we could have broken the climate and the models would no longer work. Instead of abandoning science for wild speculation, let's examine the possible factors responsible for the abrupt warming that Gavin Schmidt dismisses by saying they could explain at most a few hundredths of a degree, for which he has little evidence. El Niño is unlikely to be responsible for the simple reason that such abrupt global warming is unprecedented in our records, and El Niño has many precedents. In addition, El Niño warms a specific region of the equatorial Pacific and primarily affects the Pacific, while the 2023 event warmed parts of the North Atlantic to an extraordinary degree. This does not prevent scientists like Jan Esper and Ulf Bungen from saying that 2023 is consistent with a greenhouse gas-induced warming trend amplified by an El Niño. They clearly did not examine the data before writing this, nor did the reviewers of their Nature paper. The relationship between the temperature of the equatorial Pacific and that of the global ocean during an El Niño is shown in this figure. The temperature anomaly in the Pacific Niño 3.4 region shows the very strong Niños of 1983, 1998, and 2016, and the strong Niños of 1988, 1992, 2009, and 2024. The years correspond to the month of January during the event. When the satellite global ocean temperature anomaly is plotted without its long-term trend, we observe a very close correspondence. The long-term trend responds to other causes, but the temperature variations correspond to the export of heat from the equatorial Pacific to the rest of the globe. We also observe two things. The first is that the correspondence fails in two periods. In 1992, as a result of the Pinatubo eruption a year earlier, and in 2024. The second observation is that in all strong or very strong Niños, the source of the heat, the equatorial Pacific, warms earlier and warms more or as much in relative terms as the global ocean warms later. This does not happen in the 2024 El Niño. The warming is simultaneous and greater than it should be outside the equatorial Pacific. The Pacific Decadal Oscillation, PDO, is often described as a long-lived pattern of climate variability similar to El Niño in the North Pacific. And this is evident when we compare the two after removing a long-term trend that the PDO should not have. The agreement is very strong, and again we see a significant anomaly in 1991 due to the Pinatubo eruption. But even more important is the anomaly in 2023-24, when the PDO shows extraordinarily small changes and remains negative when it should be positive. To understand this response, one must consider that the warm phase of the PDO requires the Northwest Pacific to be cold, but as we have shown above, the Northwest Pacific was very warm in 2023, causing the PDO to remain in a cold phase. A negative phase of the PDO during El Niño is unprecedented and categorically rules out El Niño as the cause of the abrupt warming that has puzzled scientists. In fact, it is possible that the ocean warming that began in March 2023 was the cause of the 2024 El Niño, by weakening the trade winds in the equatorial Pacific. I'd like to thank Charles May for bringing this data to my attention and for doing such an excellent job analyzing it each month. Another possibility that is under consideration is the reduction of sulfate aerosols as a result of the change in marine fuel regulations in 2020. The reduction in sulfur emissions since the late 1970s is considered a significant warming factor by reducing emissions of shortwave radiation reflected from the atmosphere. However, the reduction in sulfur dioxide emissions from marine fuels since 2020 is estimated at 14% of total emissions. A recent study, still under peer review, used a climate model to calculate that sulfur emissions reductions from 2020 could cause a global warming of 0.02 degrees Celsius in the first decade. Since the warming in 2023 was 10 times greater, it is difficult to believe that emissions reductions since 2020 could have been a major factor in the abrupt warming in 2023. In the figure, the blue curve is the global warming predicted with the previously used marine fuel, and the red curve is the one predicted with a fuel with 80% less sulfur. The difference between the two curves for the decade 2020-30 is the green bar of 0.02 degrees. The amount of CO2 in the atmosphere has increased slightly by about 2.5 parts per million in 2023. The increase from 418.5 to 421 ppm represents an increase of 0.6% and is similar to the increase that has occurred each year for the past several decades. Nothing in our knowledge of the effect of CO2 increases on climate suggests that such a small increase could have led to such a large and abrupt warming. There is no study to suggest that the gradual increase in CO2 could lead to a sudden increase in climate variability. Therefore, all model predictions are long-term and affect the statistics of weather phenomena. The proof is that scientists and models cannot explain what happened in 2023. Just over a year before the abrupt warming, in January 2022, an extremely unusual volcanic eruption took place in Tonga. How unusual? It was an eruption of V5 explosivity, capable of reaching the stratosphere, which occurs on average every 10 years. There have been a number of eruptions with V5 or higher in the last 200 years, although not all of them have affected the global climate. This figure shows with dots the date they occurred and the elevation at which the volcanic cone was located. The yellow bars show the distribution of eruptions in 500-meter elevation bins. The Tonga eruption was a submarine explosion at very shallow depths, about 150 meters below the surface. It ejected 150 million tons of water into the stratosphere. In our 200 years of records, there is only one another submarine eruption with V5, which occurred in 1924 off the Japanese island of Iriomote, at a depth of 200 meters and did not affect the atmosphere. Only surface effects were observed. NASA scientists believe that the Tonga explosion occurred at the right depth to project a lot of water into the stratosphere. This depth is indicated by the red line, so the Tonga eruption is a once-in-200-year event, probably less than once in a millennium. Science was very lucky. We are not so lucky. We know the strong volcanic eruptions capable of reaching the stratosphere can have a very strong effect on the climate for a few years, and that this effect can be delayed by more than a year. The eruption of Mount Tambora in April 1815 had a global effect on the climate, but it took 15 months for the effect to develop, during the year without a summer of 1816. These delayed effects coincide with the appearance of a veil of sulfate aerosols in the northern hemisphere atmosphere due to seasonal changes in the global stratospheric circulation. In this image, on the vertical axis, we observe the water vapor anomaly in the stratosphere between 15 and 40 kilometers altitude, with ochre tones for negative values and greenish for positive ones. The measurement takes place at 45 degrees latitude in the northern hemisphere. On the horizontal axis is the date, and we can see that the large anomaly created by the Tonga eruption does not appear in the northern hemisphere until 1 year later, in 2023, when the warming occurred. Thus, there are dynamical events in the stratosphere that have the appropriate time lag to coincide with the abrupt warming in 2023. Because the Tonga eruption is unprecedented, there is much about its effects that we do not understand. But we do know that the planetary greenhouse effect is very sensitive to changes in stratospheric water vapor, because unlike the troposphere, the stratosphere is very dry and far from greenhouse saturation. As a group of scientists showed in 2010, the effect of changes in stratospheric water vapor is so important that the warming between 2000 and 2009 was reduced by 25% because it decreased by 10%. And after the Tonga eruption, it increased by 10% because of the 150 million tons of water released into the stratosphere. So we could have experienced much of the warming of an entire decade in a single year. The stratosphere has already begun to dry out again, but it is a slow process that will take many years. In 2023, only 20 million tons of water returned to the troposphere, 13%. On the one hand, we have an absolutely unprecedented abrupt warming that the models cannot explain and that has scientists scratching their heads. Such anomalous warming cannot logically respond to the usual suspects: El Niño, reduced sulfur emissions, or increased CO2, which have been going on for many decades. On the other hand, we have an absolutely unprecedented volcanic eruption, the effects of which we cannot know, but which, according to what we know about the greenhouse effect, should cause significant and abrupt warming. Of course, we cannot conclude that the warming was caused by the volcano, but it is clear that it is by far the most likely suspect, and any other candidate should have to demonstrate its ability to act abruptly with such magnitude before being seriously considered. So why do scientists like Gavin Schmidt argue, without evidence or knowledge, that the Tonga volcano could not have been responsible? If the effect were cooling, the volcano would be blamed without a second's hesitation. But significant natural warming undermines the message that warming is the fault of our emissions. Let's listen to the UN Secretary General in a recent speech.
Dear friends of the planet, today is World Environment Day. It is also the day that the European Commission's Copernicus Climate Change Service officially reports May 2024 as the hottest May in recorded history. This marks 12 straight months of the hottest months ever. For the past year, every turn of the calendar has turned up the heat. Our planet is trying to tell us something, but we don't seem to be listening. But like the meteor that wiped out the dinosaurs, we are having an outsized impact. In the case of climate, we are not the dinosaurs, we are the meteor. We are not only in danger, we are the danger. The truth is, global emissions need to fall 9% every year until 2030 to keep the 1.5-degree limit alive.
They avoid talking about this warming being natural because it contradicts the false message that the warming is entirely the fault of our emissions. It is more useful for them to talk about how we are entering uncharted territory and need to redouble our efforts to urgently reduce our emissions. It is more useful for them to mislead people than to tell them that this 0.2 degrees Celsius is perfectly natural and that they just need to wait a few years for the extra warming to disappear. This is not the era of global boiling, it is the era of global lying. This video we just saw, it goes through several points that are important that we go in more detail regarding what is going on, really, and what the United Nations and some scientists are doing. I'm going to share with your audience a slide that I'd made based on a post by Roy Spencer, in which he says very clearly that what we're doing now is what we're seeing is a natural climate event. Okay, so here what we see is that UAH global temperature anomaly. Here is the trend. The trend is calculated by a linear regression from the data, and it comes as plus 0.014 degrees Celsius per year. Okay, so this trend is what is being discussed if its origin, if it is human caused or not. So the IPCC, this is human caused. Other people, other scientists believe only partially human or maybe mostly natural, right? But on top of that, we have a lot of variability. So this variability comes every year. So some years come above the trend, and some years come below the trend. And this is known by every scientist, every climate scientist knows that this is fully natural variability because the supposed human effect on climate is a small addition every year that should be responsible for the trend. And this is very clearly stated by the IPCC in its sixth assessment report, even with an example in which human-caused climate change will be a human walking his dog, and then the dog goes around, and the dog will be natural variability, but the human is the one that is set the long-term trend, the walk where it's going. So they say so specifically in the report, and every scientist knows that annual variability and even decadal variability is fully natural. So what we're seeing here basically is all these bars, red bars and blue bars, are the difference from the trend in every year. And what we're seeing here is the action of the El Niño and La Niña years that we can recognize. For example, 1998, 2016, we see here also volcanic eruption years. We see the effect of oceanic oscillations, the Atlantic multidecadal oscillation, that they push some years up and some years down. And we even see the effect of the solar cycle here. So all those factors, all those natural factors, and maybe some more that we don't know much about, are the ones that are resulting in some years being above the trend and some years being below the trend. And everybody knows this, that, you know, this annual variability is perfectly natural. So these scientists know that when they are blaming humans for what is going on in 2023 and 2024, they're actually lying. They know the truth. And the thing is that the years that are above the trend are the ones that are newsworthy, and, you know, there's a lot of news about them. But the years that are below the trend are not newsworthy. But both are going to take place. So in the end, since you have a trend that has been going on for 45 years, you know, every year that comes above the trend will eventually be compensated by another year that comes below the trend. And in the case of the 2023-24 event, which is very likely due to the volcanic eruption, as we have seen, then we may see a few years above the trend, and then we will see a few years below the trend later on. And there's really nothing that we should be doing about this. But the scientists and the United Nations are pushing their agenda by taking advantage of this natural climate event as if we were in some sort of emergency when we're not. And if they know they're lying about this, because they perfectly know that all this variability is, as Roy Spencer tells us, absolutely natural, then, you know, how do we know that they're not lying either about the long-term trend and it's only partially human and partially natural? Because, you know, when somebody, you know, is lying, then you cannot trust what they're saying about other things. So basically, this is very important because people should know that over this year and the next year, there's going to be a lot of noise about this climate emergency, and they're trying to get advantage of this, and we should resist that, basically.
I'm curious that it looks to you like it is going to be a few years for that stratospheric water vapor to settle out, right? Maybe it went down 13% in a year or so far.
Yes, that's correct. It may take quite a few years. We actually don't know much because the way the water vapor comes out of the stratosphere is not the same as the way the sulfate aerosols when there is a normal, a regular volcanic eruption. So we don't know, but it seems that it may take quite a few years, maybe 5, 6 years, or maybe even some more, until the situation comes completely back to normal. But I would expect 2024 to be warmer than 2023, but from then on, we should see that years start being less warm and less warm.
In your graph, it started, I think, in 1979, but that also was maybe the end of the global cooling scare. So we did start at a low point. If it's kind of a sine wave, that graph starts at a lower point. Isn't that correct?
Yes, that is correct. There was a cooling period between about 1945 and 1975 that is quite well registered by surface records of the time. And after that, in 1976, global warming started again. There was a period of global warming early in the 20th century, between about 1920 and 1945, which could have not been due to the increase in CO2 because there was not much increase of CO2 in those years. And then we have the late 20th century warming that starts around 1976. So yes, we started taking the records in a period after some cooling and some Arctic sea ice growth and everything. So starting from a low point, it always looks like scarier that you're going up. But then, all these things, there are some cycles around oceanic oscillations and things like that. So in the end, the warming will not be as much as predicted by just extrapolating the warming that we have seen since 1976. It will probably be much less, and it will not be a problem. It should not be a problem for us. We can adapt, and as long as we have cheap energy and abundant energy, we shouldn't be worried about, a little bit warming or a little bit cooling.
So it seems when alarmists are talking about the cooling between 1940s and 1975 or so, they either deny that it happened or they said, okay, it happened, but human aerosols caused it. Do you see any evidence that human aerosols were the reason for that cooling?
Well, actually, the IPCC says that it was not human aerosols that caused the cooling, because when one analyzes the data presented in the sixth assessment report, the human effect on climate has been positive for the entire 20th century. So human effect on climate, according to IPCC, has warmed the climate during the entire 20th century. And this is what the models say. So even though it is true that there was some sulfate aerosols being put into the atmosphere by the industry in those years, the combined effect with the amount of greenhouse gases turned out to be positive in general. So the cooling cannot be due to humans. The cooling has to be natural. And this is what the IPCC says.
Okay. I do see quite a few articles talking about the recent warming, and the total message is scientists are scratching their heads and they just don't know what caused it. But you think they do know, they're just not admitting it. They know it's Tonga mostly?
Well, scientists don't like to say things they are not quite sure, particularly things they don't have much evidence about. And the problem with the Tonga eruption is that it's completely unprecedented. As I say, maybe there was something like that 1,000 years before, or who knows when, but we haven't seen anything like that. So we don't know exactly, what effects this type of eruption has. So scientists cannot say it was the Tonga eruption because they don't have the evidence to say that. But we do have the evidence to say it was not El Nino, or it was not an oceanic oscillation, and it was not a human effect on climate, because models do those things quite well. Particularly El Nino is more or less reproduced by models, and we have had many El Niños and La Niñas, and we know the effect they cause, and the models know, and this is completely different, so it cannot be.
Do you think scientists really have any sense as to what's going to happen with volcanoes in the next 10 or 20 years, or are we just going to be surprised that we can't really predict what they're going to do?
I don't think we have any capacity to predict volcanic eruptions. Basically, we get a big one every decade or so that's capable of affecting the climate, and that's simply a statistic. I think they're working hard in trying to know when a volcano is going to erupt, but it's just too difficult, and there's too many volcanoes on Earth.
Very roughly off the top of your head, how often do you think we could expect a year without a summer? Is it like every 1,000 years? Not, I know it's not predictable, but how rare is that?
I would say that is quite rare. I think maybe once every 500 years or something like that, we could get something like Tambora in 1815. Something so strong is not very frequent. So I think one can live with that kind of danger. Shouldn't worry us too much, right?
Right. And you did say within the presentation or within your video that if we get that huge volcano, we wouldn't necessarily have the skip the first summer. It might be the second summer, right?
Yes, that's right. It depends what time of the year it happens, because atmospheric circulation in the stratosphere is quite different from the troposphere. So most of the circulation is directed towards the pole that it's in winter. From the entire stratosphere, not the lower stratosphere, but the middle stratosphere and upper stratosphere, the atmospheric circulation goes towards the winter, from the summer pole towards the winter pole. So if you have an eruption early in the year, or January like Tonga, or April like Tambora, what is going to happen is that the circulation is not going to affect the northern hemisphere climate that summer, because it is going towards the southern hemisphere and the South Pole, and it will be after the winter, the next winter, when the full effects will be noticeable. And in fact, most tropical volcanic eruptions that are capable of affecting the climate through putting a lot of sulfate aerosols in the stratosphere, they tend to cause a warmer winter in the northern hemisphere after the eruption, and also an El Nino in the Pacific. So this has been studied quite thoroughly. There's quite a lot of bibliography showing that it affects El Nino and it affects the polar vortex.
And this might not be a fair question for you, but if we had another Tambora, let's say next year, how do you think humanity would handle it? Would we figure out a way to still feed everybody and get through it, or how bad would it be?
It will be quite hard, because there's a lot of people in the world, and there's not much food storage. We only have food stored for a few days, like a month or two. So if it affects a lot agricultural production, then we will have a rough year, that's for sure. The thing is that since the climate is not affected the same way everywhere, we could still have good agricultural production in some parts of the planet, while other regions will have a very bad. So since we have the capacity to move food around, and we will go through a period with very high food prices and problems, but I think we would manage probably better than they managed in 1816 or 1817, since the ability to move a lot of food from one place to another was much lower.
And I'm just curious about the chance of a really bad volcano causing 2 summers in a row to be missed. Do things settle out fast enough so that is extremely unlikely?
Yeah, I would think that's quite unlikely.
Okay, very good. Let's see. Any other points you'd like to make before we finish this one up?
No, I think that was it. Thank you very much.
Okay, thank you very much. I appreciate your work.